Hi everyone. So this is our second lecture of on differential equation. Okay, and we are discussing variable separable type. So we have this problem. Okay, in this lecture we are going to solve total three problems, uh, which are of variable separable type. So this problem is given and we have to solve. So what will I do? First of all, I will write the given problem. So this is a given problem. So you remember, in case of variable separable type, what we do? We take all terms of x on one side and we take all terms of y on another side. So what will I do? I will shift this term of dy on that side. Okay, then we will have, I copied the same term. Okay, I'm just shifting this term on that side. It has a plus sign here. So if you shift it there, it will have a minus sign. Okay, so in this way we got this step. Okay, so dx is here. That means terms of x should be on this side and dy is there. That means terms of y should be on that side. So because of that, here we have a term of x. So I will shift it here, and here this is a term of y. So I will shift it there. See, here is multiplication. So if you shift it here, you will have a division. Similarly, here is also multiplication. So if you shift it here, we will have a division. So therefore, we have dx upon root 1 minus x square. I shifted it here. Similarly, this square root I will shift on that side. Here is multiplication. There we will have division. So in this way, we have separated the variables. Here in left hand side, we have all terms of x. In right hand side, we have all terms of y. So now we can integrate both sides. We are integrating both sides. So we integrated left hand side. Similarly, I will integrate right hand side also. Okay, and plus constant of integration. Okay, to solve these two integrals, you must know one formula of integration. Okay, I will write that formula here. Do you know this formula, integration dx upon root a square minus x square? Do you know this formula? Yeah, what is it? It is sine inverse x by a. Okay, this is a formula we have. See, we can use this formula to solve both integrations. So if you think about this integration, the same formula we have. Instead of a, we have 1. Okay, so here also I can put a is equal to 1. And what will be, we have, this is sine inverse x by 1. That means x only. Okay, so minus here also we can use the same formula, right? So at a place of a, what we have, 1, and instead of x we have variable y here. So can you tell me what will be the value of this integration? Yeah, obviously it is sine inverse, at a place of x we have y and value of a is 1, so plus c. So you can do this one thing. So here is a minus sign now. So if you shift it there, it will have a plus sign. So we got plus sign. After shifting this minus sign on that side, is equal to now only in this side we have a c. So this is a required solution of given differential equation. Okay, so let us solve one more problem. Okay, see, this is our second problem. This problem we have to solve using variable separable method. So what will I do? I will rewrite the question again. Okay, I'm starting solution from here. I will write the given differential equation is. So as I told you, we have a dx on this side. So all terms of x should be on this side, right? We have dy on this side. So all terms of y we should collect here. So see, dx is here. So this is term of y. I should shift this term on that side. Here is multiplication. So if you shift it here, you will have a division. Similarly, dy is here and we have one term of x. So I should shift this bracket on this side. So here is multiplication. If you shift it here, you will have division. So let us do that. Okay, so what I have done, e raised to x dx, I wrote as it is. This is term of x, so I shifted that term on this side. Okay, so let us do the same here. 2y dy, I will copy here. And we have one term of y, this bracket on that side, so I will shift it here. So there is multiplication, we will have division here. Okay, so we have all terms of x on this side and all terms of y on this side. So let us integrate both sides now. So now it is a variable separable type. So I will integrate both sides. Let us see what we'll get if you integrate both sides. See, integration of left hand side. Similarly, I will take integration of right hand side. Okay, so plus constant of integration c. Okay, So see which formula we have to use. Let us see which formula we have to apply here. I am going to write one formula here. Do you know this formula, integration f of x, integration f dash of x upon f of x? That means in simple words we can say derivative of denominator should be at numerator. Then its formula is log of f of x. Okay, this is our formula. Okay, so this formula we have to use. See, let us see, can we apply this formula or not? This is denominator. What is derivative of denominator? You must know for basic formulas of derivative. Derivative of e raised to x is e raised to x. Derivative of 1 is 0. So no need to write 0. So that means in a simple words we can say derivative of denominator is numerator we have got. So I can apply the formula. Can you tell me using this formula what can I write? Therefore, yeah, using this formula, log of what? F of x. F of x means denominator. So what is denominator here? E raised to x plus 1. So this is required value of this integration. So let us go for this right hand side. This is denominator. What is derivative of y square? Derivative of y square is 2y. Yeah, okay. What is derivative of 1? 0. So that means what is derivative of denominator? 2y. So we have got derivative of denominator at numerator. So we can apply this formula. Will you tell me using this formula what can I write? So this is log f of x means denominator. What is denominator here? Y square plus 1 plus c is here. C is there. But both sides you have got log. So I will call it as c1. C1 means log c. Everywhere we have got log. So here in constant also I am taking log. So there is one property of log. Do you know? Log a plus log b. Do you know this formula? This log a plus log b. That means log a into b. Log a plus log b is log a into b. So that means if addition of log, you can take the product of their terms. So I will write left hand side. Okay, when you write right hand side, I will apply this property of log. Will you tell me what can I write? Log. See, I will take product of these two. C y square plus 1. So see, in next step what will happen? Log will get cancelled of both sides. So e raised to x plus 1 is equal to c y square plus 1. So this is a required answer of given differential equation. Okay, so this is our third problem. Okay, the previous problem, two problems we have seen. Let us try for this third problem. So first of all, I will write the given differential equation. See, we have this given differential equation. So we are trying to make those variable separate. So before that, one constant is there. Now, so what will I do? I will shift this constant on that side. So here is a plus sign. If you shift it there, we will have minus sign. So after shifting this one on that side, we have got this differential equation. So see, we have to make those variables separate. So for that, I will shift dx on this side. Okay, so what will you get? See, x plus 1 dy is equal to, I am shifting dx on this side. Okay, so we get this is. See, dx is here. That means all terms of x should be on this side. So here we have a term of x. So I will shift this term on this side. As well as dy is here. That means this term of y should be on this side. So let us do this. Okay, so I shifted this bracket on this side. In multiplication is here. So I shifted, after shifting, we have a division. And here also dx upon, after shifting that bracket here, multiplication is there. So we'll have division. So that means here all terms of dy on one side, all terms of dx on another side. So see, now this is variable separable type and I can take integration of both sides. See, integrating both sides, we get integration of left hand side. So now we'll take integration of right hand side plus constant of integration c. See, let us see how to take integration now. The task is not that much simple. So some adjustment we need to do. But before that, what will I do? See, what will I do here? Dy upon power has a minus sign. So what will I do? I can write 2 upon e raised to y. It is negative sign. Power has negative sign. So I shifted a denominator. So we'll have a plus sign. Minus 1. This is equal to. Here, I will copy as it is. Dx upon x plus 1 plus c. After that, what will I do? we can cross multiply here. Let us write on the next page now. Okay, so after cross multiplying, I got this term. I copied the right hand side. So this e raised to y is in denominator of denominator. So we can shift at numerator. It is in denominator of denominator. So I will shift to the numerator. So after that, after shifting e raised to y to the numerator, we got this one. See, this left hand side I will copy as it is. Sorry, right hand side. See which formula I am going to use. I am going to use this formula. Integration f dash of x upon f of x dx. Already we have seen in last example, right? What is it? It is log f of x. So that means if you have derivative of denominator at numerator, you can apply the formula. What is derivative of x? 1. 1 is there. Okay, nothing is there. That means 1 is there. What is derivative of 1? 0. Getting? So the final derivative is 1. So that means I can apply this formula here. Since derivative of denominator we have got at numerator. Let us think about this. What is derivative of 2? 0. What is derivative of e raised to y? E raised to y, right? But see, minus sign is there, so that sign should be there. So that means what we have to do? We have to simply adjust the sign. Okay. Okay. So I adjusted minus sign here, both minus minus plus, okay. So the purpose is derivative of denominator we have got at numerator. So let us apply this formula. Minus sign I copied as it is. So by applying formula, log of denominator, what is it? 2 minus e raised to y. Here what will happen? Derivative of denominator is numerator we have got. So this is log of denominator. That means x plus 1 plus c, constant of integration. Instead of c, I will take c1. Our c1 means log c. Since everywhere we have got log, so I will do the same. Log 2 minus e raised to y is equal to log x plus 1 plus log c. c1 means log c. You know the property of log. Okay, I will copy as it is. So I copied as it is. You know the property of log. Log a plus log b means log a into b. So this is log c into x plus 1. I will shift this. There is one more property of log. If you know, I will write here. Log n log a. Do you know n log a means what? Log a raised to n. This is the one more beautiful property of log. See, this property I can apply here. So minus means n here. So minus 1. So it will shift to the power. So we will have log 2 minus e raised to y raised to minus 1, which is equal to log c x plus 1. Okay. So I can cancel log on both sides. So what will I get? 2 minus e raised to y raised to minus 1 is equal to cx plus 1. Right? See, it has a power, it's minus 1. So you can shift to the denominator. So this is 1 upon 2 minus e raised to y. Getting now? So power is 1 now. So this is equal to c x plus 1. So it is in denominator. You can shift here. So it will be numerator. So 1 is equal to c x plus 1 2 minus e raised to y. Or simply this term I will shift to this side. See, this term I shifted on this side is equal to 1. So this is a required solution of given differential equation. So 3 problems we have discussed here. Thank you.